Hello everyone, you are welcome to today's class. So in this video, we want to look at variation. So under this topic, we'll be looking at the following. We want to look at the meaning of variation, types of variations and problems on the types. So now be looking at the types one by one. So firstly, let's look at the meaning of variation. So when we talk about variation, variation will be described as the relationship that exists between two or more quantities, that is variables. So in which a change in one quantity leads to a change in the others. So that means, so if something should happen to one of the quantity, let's say maybe we increase one quantity, so the other quantity, there will be a change in that one, the other quantity. Either it's going to be increased or it's going to be what? Decrease. So the relationship is what we call a variation. So we now have different types of variation. We have just four types of variation. We have direct variation, we have inverse variation, we have joint variation, and we also have what? Partial variation. So what we're going to do now, we'll now be looking at the types one by one and solve problems on them. Right. So we start with direct variation. Direct variation. So in this type of variation, an increase in one quantity will lead to increase in the other quantity or quantities, and a decrease in one quantity will lead to what? A decrease in the other quantities or quantity. So that means that the direction, they are facing the same direction. That's why they are direct. So if one should increase, the other one will also what? Increase. If one is should decrease, the other one should also what? We also what? Decrease. So which means a decrease or an increase in one will lead to what? An increase or a decrease in the other. I hope this is very clear. Will lead to an increase will lead to increase. A decrease will also lead to what? A decrease. So that means they're moving the same direction. That is, if this one is increasing quantity, this first quantity is increasing, the other quantity will also what? Increasing. Are you with me? So quantity one, if it's decreasing, this quantity two also what? Be what? Decreasing. That is, when one variable is increasing, the other variable will also be what? Increasing. It will lead. So increment in one will lead to what? Increment in the other. Are you with me? And a decrease in one will lead to a decrease in the other. So we are going to look at example on direct variation and how we're going to solve them. So that's what we're going to look at next. Alright, for direct variation, the first one we have here, so we have, let's look at examples. So the first one, if x varies directly as y, if x varies directly as y, and x is 3 when y equals to 7, so find the value of x when y is equal to 4. Now, before we solve this, so there's something, let's interpret. The way we are going to interpret is very careful. So x, solution here. Solution. So we're going to have x varies. So we write x. So varies, this varies. So the symbol is written this way. X varies directly as y. As y. So that is interpretation from here to this place. X varies directly as what? Y. Is that clear? So where this symbol means varies directly or proportional to, varies directly or proportional to. Now, we cannot solve anything with this symbol. So we have to change it to mathematical equation. So we are going to change this variation symbol to equals to. As we are changing the variation symbol to equals to sign, we must introduce a constant. So therefore, this will now change to x equals to ky. Where k here, where what? K is what? A constant. We are only introducing the constant because we have changed the symbol to what? equals to sign, we must introduce what? A constant. Hope I'm with you. So if that is the case, the next stage we can then move on, and x is 3. X is what? 3. When y is what? 7. When y is equal to what? 7. We stop there again. So we now use the value of this variable to find the constant. We use the value of the variable to find what? The constant. X has been given to be 3 and y has been given to be what? 7. We now substitute them into this to get the value of our what? Constant. I hope I'm making sense. So in that case, we're going to have, instead of us to write x here, we write 3 equals to k multiplied by the constant at the y, which was 7. So this means that we are looking for k, not 7. So we divide both sides by what? 7. Divide both sides by what? 7. Therefore, this we cancel what? This. So we can then conclude that k equals what? 3 over what? 7. I hope I'm making sense. Right? Good. We have known the value of our constants. So the next thing is to now find the relationship between the two variables. So whether you are asked to find the relationship or you are not asked to find the relationship, it is a must for you to write out the relationship between the two variables. So what does that mean? So it means that we are going to put the value of the constant k into this equation. So that means we substitute k, the value of k, into this equation. Therefore, x will then be equals to k, which is what? 3 over 7, and then y. So we will now consider that x equals to what? 3y over what? 7. So this expression here is called relationship. Relationship between what? Between x and what? Y. Any variables are given, it depends. So we also call it formula connecting the variables, or we call it equation connecting the variables. So anyone use that, they mean what? The same thing. So we've not found what we asked to look for. We have to find, the question asks us to find the value of x when y equals what? 4. So we can then use this. So find x is x we're looking for when y equals to what? 4. Are you with me? When y equals to 4. So therefore, we now substitute y into this equation to get the value of our x. So therefore, we make use of this. That will be x equals to 3 multiplied by y, which is 4, divided by what? 7. So this will give us 12 over what? 7. Therefore, x will then be equals to 1 whole number 5 over what? 7. I hope this is very clear. Is that clear? I hope this is very clear. So this is what we refer to as what? Direct what? Derivation. So we're not going to look at another question again. Alright, this is the second example. So let's interpret this. This is a bit longer than the first one, but they are almost the same thing. So the only difference is just we have some words written there. So the first f, that means we are making f, using f. So we are making use of f, solution. So the first f, that is f, exerted by a spring is directly proportional. Directly proportional. You know, I said the symbols could also be directly what? Proportional. Is directly proportional to its extension x. To its extension x. Is the first is directly proportional to its f is directly proportional to what? X. That is just the interpretation there. That's what we needed here. F is directly proportional to what? X. F is directly proportional to x. That is it. So we stop there, then we interpret this. This will then be equal to f equals to kx. We have introduced a constant k here. So if a force, that is f, of 8.5 Newton, that is f is 8.5, produces an extension is what? X. That is x when x, that's meaning when what? X equals to what? 2.5 centimeters. 2.5 centimeters. So this is Newton. Is that clear? So calculate the extension produced by a force of 27 Newton. So before that, before we come to A, we have to find the value of our constant. So how do we find the value of our constant? We just substitute the value of f and x into this equation. That's going to be 8.5 equals to k times what? 2.5. So we divide both sides by 2.5. We divide 2.5. So therefore k, we then do what? This cancel this. So 8.5 divided by 2.5. Then we have k equals to what? 3.4. So that's the value of our constant k. So the next is to write out the relationship. So we are not asked to find relationship again. You can see. So we must write out the relation. That will be f equals to 3.4 what? X. So this is the relationship. Am I with you? So the next, so let's now go to A. Roman figure A. Roman figure A. Calculate the extension produced by a force of this. That means we are looking for x and f equals to what? 27. So we make use of this. So f, which is 27, equals to what? 3.4 what? X. So you divide both sides by what? 3.4, 3.4. Therefore, x equals to this, cancel this. So 27 divided by 3.4, and that gives us 7.94. Right, centimeters. Then B, calculate the force. That is, here we are looking for F, when x equals to produce an extension of 5.5. So where x equals to what? 5.5. So we also put that in this equation. That's going to be F is what we're looking for. 3.4 times 5.5. So therefore, 3.4 times 5.5 equals to 18.7. 18.7. I hope this is very clear. So let's look at one more example before we end this. We stop on direct duration. Okay, this is the third example under direct duration. So let's quickly solve this before we move to inverse duration. So under this, if D varies directly as T, D varies directly, this one is very straightforward. So D varies directly as what? T. So that's the first thing. So the next thing is to what? Is to change this symbol to equals to, that would then be D equals to what? KT. KT. So and D is this, when T is 12. So we are looking to have D equals to 20.5 when T equals to what? 12. So we need to find the value of the constant. So we need to find the value of the constant. So by putting this, D replaced with 20.5 equals to K multiplied by what? 12. So we divide both sides by 12 by what? 12. This cancels this. Therefore, K will then be equal to 20.5 divided by 12. So that gives us K to be what? 1.7. So K equals to 1.7, right? So the value of the constant that we found now, so that is what? A. This is A. Then B, find the relationship. The relationship, we just put the value of K here. That will be D equals to K 1.7 what? T. Then that is that. For C, the value of D when T equals to C. So we are looking for D. D we don't know. And then T equals to what? Equals to 6. So that means D equals to 1.7 times what? 6. So 1.7 multiplied by 6. So this gives us D equals to what? 10.2. I hope this is very clear. So let's now just look for, talk about inverse variation. Alright, let's look at this inverse variation. So inverse variation is just the opposite of direct variation. So we just have a slight difference between the two of them. So only one thing will make them different, and that is the word inverse. So under is, now before we look at inverse variation, when you have a number 2, let's say we have these two. We want to get the inverse. Inverse of a number, we have a multiplicative inverse. Let me put multiplicative inverse of 2 here. So means we are looking for a number that we multiply with 2 to give us what? 1. So what are we going to multiply by these two that will give us, that we're going to get what? 1 as an answer. That is 1 over 2. You can see this 1 over 2 is the opposite of what? 2 over 1, because this one is 2 over 1. So the inverse of 2 here is what? 1 over 2. So we say anytime you hear the word inverse, we are talking about 1 over something. So if I say inverse of 3, that is 1 over 3. Inverse of 5, 1 over 5. That is multiplicative inverse of 3 is 1 over 3. Multiplicative inverse of 5 is 1 over 5. So we are now going to use that concept here to solve problem on what? Inverse variation. So in that case, we look at this example and see how we're going to interpret that. How do we interpret this? So y varies inversely as x. So to interpret this solution now, so it means y varies inversely. That's the word inverse here. Will then be 1 over as x over x. Do you understand? Let me interpret again. Y varies inversely. That inverse is 1 over as x over x. Are you with me? So this is the difference. But if it is direct, the word inverse here will not be there. You see that you have directly proportional to or direct or varies directly to. You understand? Directly proportional to or varies directly to. Do you understand? But other inverse, you see that inverse there. So hope that is very clear. So this one, the same thing will be done. We're going to change this symbol to what? Equals to. So we're going to have y equals to k multiplied by what? 1 over x. So that means we're going to have y equals to what? K times 1 is k over what? X. That is that. So we can then go ahead and solve the next one. Y equals to 15. Y equals to 15 when x equals to what? 7.5. We are now looking for k. So we substitute this. That will be y, which is 15, equals to k divided by what? 7.5. So when we cross multiply, we are going to have k equals to what? 15 times 7.5. So 15 times 7.5 gives 15 times 7.5. That gives 112.5. That the value of our k here is what? 112.5. That is k equals to 112.5. So that is not what we're looking for. So the question asks us to find the equation connecting y and x. You know, I said equation connecting y and x. So that is looking for what? Relationship. We just put the value of our constant into this equation. So a now, a will then be y equals to k 112.5 divided by what? X. That's all. So find the value of a. Then b. So find the value of x. That is, we are looking for x when y equals to what? 10. Right? So we are now going to substitute the value of y into this. So that is going to have y, which is 10, equals to 112.5 divided by what? X. Right? So the next thing, this is over 1, we cross multiply. So 10 times x gives us what? 10x equals to 112.5. So we divide both sides by 10. By 10. So 10 cancels 10. So this will give us what? So 1, that is 11.25. So that is that on this. I hope this is very clear. So let's look for one more example before we end this video on variation, inverse variation. Alright, so this is the second question under inverse variation. According to Boyle's law, the pressure P that is P, we are looking at P, of a given mass of gas at a constant temperature varies inversely. So that is P. To solve this, P varies inversely as its volume V, as what? V. So if P is this, so before that, we need to change this to equals to. So this will then be P equals to K over what? V. Are you with me? Now, so if P equals to 60, right? When V equals to 40, V equals to 40. So find the formula connecting. So that means find the value of constant, then put it into this equation. So let's find the value of constant. That would be 60 equals to K over what? 40. So we cross multiply. That is K equals to what? 2,400. So to now find the formula connecting then will then be formula connecting P and what? And V will then be what? P equals to 2,400 divided by what? By V. Then you're going to find the value of P when V equals to 5. That is 2,400 divided by what? 5. So this 5 here 1, 5 here 4, remaining 4 in 40. That is 8. That is 480. So that is that on this topic, inverse variation. So we still have joint variation and partial variation, which cannot be covered in this video. So in the next video, we look at the remaining two types of what? Variation. So this is what we're going to stop in this video. If you are new to this channel, don't forget to subscribe and make sure to put on your notification bell. So anytime I release video like this, you get notification of it and benefit from it on time. And if you find this video useful and helpful, don't forget to give us a big thumb up and write in the comment section what you have found interesting in this video. And don't forget, you can also share this video with your family and friends. So we meet in our next video. Bye for now.